Hello guys, it's your guy Vierra from Vierra Manufacturing Services. Welcome back to my tutorial. In this tutorial guys, we are going to be generating the M&G code required for VMS project 6. So guys, in the previous tutorial we spoke about milling systems. Now guys, there are actually three types of CNC system: milling, thinning and mill-turn. So guys, anytime the center of symmetry lies around the center line, then you are going to be using mill-turn or thinning system, like in this case. So this is a typical thinning system. However guys, as we notice, we got a slot, and generally when you are making a slot operation, it is a milling system. So anytime you have the combination of a thinning process and a milling process, hence you have to use mill-turn system. Or you could equally say you are going to use only a thinning system, and then you are going to unclamp the workpiece, then transfer this workpiece into a CNC milling system and then perform the milling operation. Hope you got that. So let me just show you guys some pictures. So looking at this part, we use milling system in order to do this operation. Now if you divide this part into two equal half, you notice that they are not symmetrical. As you notice, these holes are on the other side, and you are using a rectangular block, so it clearly tells you that this is a milling system. So looking at example 2, that they are not mirror images. Okay, let's go to the next example. Okay, good. So if you divide this one, you notice that its center line falls around its symmetry line equally. So now we got just thinning operations, no slot, no engraving, no milling operation at all. So this is a typical thinning system. Okay, so looking at this fourth example, you notice that if I divide the part into half, we got some thinning system. However, we got some holes at the surface, right? These holes at the surface can be mirror images of each another. So this clearly tells you that we have combination of both thinning system and milling system. When you get a part, try to divide the part into half. Like when I divide this part into half, I foresee that I can use thinning operation. However, this slot will be done only with a milling operation. So it's basically your choice. Either you are using thinning system for this particular part, and then you just have to export your part into a milling system in order to finish this. Now, but with evolution of technology, we got a new concept known as mill-turn. So what is actually mill-turn? A mill-turn is actually a CNC controller that have both turning operations and some milling operations. So looking at CNC turning, you notice that we got some operations like turning, drilling, and this drilling operation only acts within the center. Unlike in milling, we could make holes, being it in the center or being it at the edges. It doesn't matter the location. But with this drilling operation, you must be at location X00, Y00. It's actually mandatory. You should be at the center. Okay, so we have threading operation, drawing operation. We have some operations here. Now, these operations works only with CNC turning system. Now, what if you take CNC mill-turn? When you take CNC mill-turn, you observe that this turning system will be activated, and this Solicam 2.5D would equally be activated. So this is to say that mill-turn system is actually the combination of both turning system and milling system operation. Hope you got that. So in these scenarios, I'm going to be taking mill-turn, reason being that I got this slot. In the absence of this slot, I'm not going to take mill-turn. I'm just going to start directly with my CNC turning system. Hope you got that. So let's go directly for the operation. New mill-turn. So I'm going to be taking internal, making sure that your unit of measurement should be in millimeter. So this is VMS project 6. Let's say come. Go for the green check. Now the CNC machine controller, now coordinate system. So making sure that you are using center of revolution face. This is actually mandatory. If you actually start using options like top center of model, now if you select face, let's just select this. Okay, so now you notice that it actually tries to snap the center, but it is not actually at the center. If you zoom properly, you notice that this isn't at the center. but our aim is actually making sure that it should be at the center. So for this, you have to select center of revolution face. Just come over, select face, and then click on this. Okay, and click on change to opposite to make sure that it becomes in front. So when you are using turning system or mill turn system, you have to make sure that the X is looking upward and the Z is looking perpendicular to the X, just in this position. Then you go for the green check. With the presence of mill turn, you have more than one offsets. What do we mean by offsets? Now, you have to understand that when you are using turning system, you could clamp your workpiece at this position, okay, and make all the operations from the start. Now, what if you want to put a chamfer at this end point? You have to unclamp the piece, put this front as the clamping end, and then, you know, like rotate it in this direction. So the clamping will be looking at this side, and then you put the chamfer or any operation from this direction. Now, what happens is this is a manual process, right? Like you are unclamping manually. Now, but with mill turn, you could put more than one offset, in the sense that if you begin your operation from here, now because you are using mill turn, it's gonna flip the part automatically without you actually doing it manually. So it got more than one offset or more than one coordinate system. Hope you got that. So we go for the green check. Okay guys, so right now we are going to define the stock. Just come over assembly, insert component, new part. So I want to check first the diameter. If I click on the circle, it gives me about 36 mm. Okay, so 36 mm is actually the largest diameter. So for the stock collection, assembly, insert component, new part. I'll click on the surface. I'll come over here, normal, circle. Now rather than putting 36, I'm gonna put 40 for the extra clamping. Fixture, extra base. Like in the previous tutorial, we are going to use the option offset from surface. I'm gonna choose this surface. Now, I have to add extra material required for the clamping. I'm gonna take about 20 mm, reverse offset. So this material is actually used for the clamping. Now I need a little bit of extra material for the facing. So I come over direction 2, activate this. Now this material 10 mm looks a little bit quite large. Let's go for 5 mm. Okay, this is just perfect for me. I go for the green check. Okay, stop assembly. Now I'm gonna right click on the part and I come to change appearance. Stock, right click, define. So choose 3D cam, cut selection. We want to select this one, resume. Let me show. So this is our stock right now. I go for the green check. So what it's doing right now, it's actually redefining our profile. So this white line produced is what we call profile. So the profile is a path which the tool is going to follow in order to produce our work piece. So you want to ensure that the target is properly defined. Come over target, right click, show, just to verify. Okay, so target properly defined. Okay, go for the green tick. Okay, all done. So the next operation is about putting the fixture. So actually, it's very important to know that the fixtures used in many systems, it's quite different from the fixtures used in turning or mill turn system. Basically, when you are using turning operation, you use jaws. When you are using turning system, the tool isn't rotating. But in the case of milling system, the tool is rotating. So that could be equally a difference between milling system and turning system. So for the fixture, remember that in mill turn, I just insert, I come over here, insert component, I insert a fixture, and in order to tell SolidCam that this is my fixture, I come under fixture definition and I define it as a fixture. But in this case, you come under setup, right click, edit setup. Now, with table selected, you want to click on these 3 dots and come under edit. Okay, so this is actually the place where you define your jaw. Just hold down, clamping diameter. So this is actually the diameter in which the jaw is going to stand. Right now it's standing at 38. Position 38 looks somewhere here, but this is not the actual position. The actual diameter is 40, so it cannot be standing at 38. So I'm just going to select this, I'm going to highlight it and select this line. So right now it's going to stand at 40 exactly. So you have to play with these parameters in order to make sure that the jaw has a defined shape. So for example, if I come over 20 looks small, let's say 40. Okay, all perfect. So I'm actually pretty satisfied with my jaw definition. So if you scroll down, you notice that it's been asked number of jaws. So as you do know, it's based on the complexity of your workpiece. Now if you are dealing with a high workpiece complexity, you may be required to use 4 jaws in order to clamp the piece properly so that it cannot shake. Okay, because remember that when you are using a CNC Thinning machine, definitely the spindle are rotating with a high RPM. So if the workpiece is actually shaking, it may lead to accident or even damage of your turning tools. So you don't want that to happen. So I'm gonna be using 3 jaws just for this demonstration. Okay, so I'm pretty good with all this. I go for the green check. So something more, as you notice, my jaw is actually sitting at the front surface of my workpiece, because remember that the operation will start here. So it means immediately the tool will come for the facing operation, there is going to be a collision between my jaw and my cutting tool. This jaw should be at this particular point, at the end point of my piece, so that I can be cutting from this direction. Okay, hope you got that. So now, how do we tell the machine or the CAM software to actually take the jaw from this position to this position? Okay, let me show you guys this. Come under table post, make sure table post should be selected. Now machine preview. Okay, I'm just gonna shift this direction. Okay, so this is a machine preview. So right now this is the way the workpiece is actually sitting. So now if I come under these 3 dots, I pick Z. Now if the jaw is here, I want it to be here, it means I'm going to pick this line. I go for the green check. So as you notice, this is what happens. So now it is actually properly seated. Okay, so just go for the green check, and that is it. So your fixture or your jaw has been defined by doing this. Okay, so now you could just save your project. Okay, or fine. So now you go for the first operation. You come under solid cam, turning, face. So our first operation will be facing operation. I'm going to be showing you guys how to use solid in order to select the geometry, new. So as you notice, this is our jaw at this position at the end. So which part do we want to face? This is the surface we want to face. So select the surface. Where is the ending point? It is still at this surface, so I have to select this surface again. Now look upon the arrow. The arrow goes upward. Now guys, you have to think, when you are making facing operation generally, do you face from center to upward, or do you face from upward to center? You face from upward to center. So you have to reverse this direction, come over here, select direction, take clockwise. So it's gonna reverse. So now you're facing from upward to center. Go for the green check, accept, come under modify geometry. So now you want to make sure that auto extend is selected. If I unselect auto extend, for example, you see that the facing begins only from the target, right? You want to make sure that it begins from the stock. So you have to press auto select in order for it to begin from the stock, and equally you want to come down and equally select auto extend to the end of stock. Okay, perfect. So this is what happens. It comes up to the center of the stock. Hope you got that. You go for the green check, tool, select. Now for facing operation, we are going to be using an external cutting tool. I'm going to take 60 degrees, let's say. Okay, all fine. I go for the green check. So now you have to select direction of cutting. So yeah, the actual direction of cutting that you have to select is this. This is the actual direction of cutting. If you select the wrong direction, definitely you are going to have some collision, or the M&G code will not even be generated. Let's go for the levels. No levels, just safety distance. You could take safety distance of 1 or 2. I'm going to take 2. Technology. So over here, you want to make sure that you are using front. I'm going to take smooth, step over of 0.08. Okay. You just take an offset of 0.02. Retreat distance of 0.0078. Finish on. I'm going to on the compensation equally. Link. Okay. Semi slit add. Okay, all fine. Save calculate. Simulate. Now guys, when you are making a turning system or a mid-turn system, you want to make sure that you are using turning as a simulation mode, because the turning will give you actually the perfect simulation to actually know that if you are using the right tool, if your operation is properly done or not, as compared to solid verify. So solid verify is used only for milling operations. So right now this facing is under turning, so I'm going to use turning simulation. Okay, I'll start the operation. Okay, let's look at this. Okay guys, so facing actually done. So as you know, there is no rest material because I use a finishing pass. So the facing has been done. Okay, good. So what about the next operation? We have to actually remove this part. So for this, we are going to be using turning operation. I'm going to close this. I'm going to off this equally. So turning. Okay, geometry. So this surface was the surface with which we made the facing. So for the turning, we are going to select the surface. As you notice, it selects here. Okay, face 18. So where do we want to end our turning operation? You could select this surface or this surface. I'm going to go for this surface. Now, as you notice, it selects up to this point. The tool can come downward. It's not possible. So I'm going to select end. I'm going to select back the surface so that it ends exactly here. Hope you got that. Okay, all fine. You want to make sure that it's from this direction. Now if I take clockwise, you notice that it takes from this direction. No, we aren't turning from this direction, we are turning from this direction. So you want to take the other side. You go for the green tick. Okay, all fine. You proceed. The tool, I'm going to be using the same tool. Okay, now the cutting direction is actually the same. Levels, no levels, just safety distance. Technology. Now I'm gonna be using work type should be rough, long external. Let's look. Smooth facing, step down 0.04, retreat value 0.078. Just add a 0 here. I'm gonna take distance. This is actually my offset 0.0, let's say 2. Semi finish. I'm not gonna take any semi finish, no finish passes. I'm just gonna leave it with an offset. Then I'm gonna change my tool and then I'm gonna make the finishing pass with that. Okay, strategy. Now this strategy is actually important. Now because in CNC Thinning we have what we call grooving operation, right? Grooving operation is actually an internal cut in the piece. So now if you are taking descending, it means when the turning pass is going to be made, when the turning operation is going to be performed, the tool will actually try to finish that groove, which is not actually the best method for grooving because we equally have a grooving tool. So you want to make sure that you are taking non-descending. Link or fine, you go for save calculate, simulate. Okay, turning. Let's look at the simulation. Now when this turning operation is going to be made, it's going to leave a little bit of raw materials, right? Because we use an offset of 0.02 and we do not use a finishing pass. So now, without wasting time, we are going to take save copy, our trick save copy. Okay, using the same geometry, of course. Now, what happens to the tool? We are going to change our tool. We are going to be using a finish tool, so we are going to be using external cutting. This time around, we are going to be taking V35, an angle of 35 for the finishing pass. We go for OK. Okay, levels, no levels, technology. I'm going to be taking finish only. Semi-finish, no ISO. Okay, step down 0.04, compensation on. Strategy, non-descending or fine. We go for save calculate. Simulate. Thinning. Okay, let's look at this. So right now what it's doing, it's just making the finish. Okay, all fine. So guys, all this portion and this portion, it's actually the grooving, right? It's actually the grooving operation. So let me just untick this and this. So we go for the grooving operation. This is grooving. Make sure that solid should be selected. Geometry. Okay, so this grooving begins here. So I'm going to select this face because it begins here, and the grooving ends here. So I'm going to select this surface. Okay, or let's say this surface, so that it ends exactly at this point. Just perfect. Go for the green check. Okay, tool, select tool. So for grooving operation, we use a grooving tool. So this is groove. We go for the grooving tool. Okay. Okay, tool. Just come back on the select. Now, as for now, I want you guys to unselect the holders. So just right click on it and then remove. Right click, remove, or fine. Let's just use the insert as for now. Grooving. The grooving tool direction should be this. Okay, levels, no levels, technology. I'm just gonna use finish only. Okay, I'm gonna on the compensation equally, grooving parameters, or fine levels, click, all perfect. Go for the simulation, simulate, thinning. Let's look at this. All perfect. So now looking at the diagram, we got this hole to actually drill. Then we got this extra material to actually remove, and then we got slots. So the slot cannot actually show on this 2D sketch. Reason being that slot operation is not a turning operation, it is a milling operation. So what shows in this representation are only turning operations. So right now I'm going to be making the drill. So we are almost done. So let me calculate the drill diameter. So it's going to be 4.5 mm. There are actually two ways in order to make this hole. Now the hole is 4.5 mm. So either you are using a drill of 4.5 mm, or I could use a drill of 4 mm or 3 mm, and then in order to finish the hole, I'm going to use a boring tool. And let me tell you guys, this is actually the best way to do this. Use a smaller drill and then finish the hole with a boring tool. But in this tutorial, I'm going to show you guys just the simple drilling using a drill of 4.5 mm. In the next tutorial, we are going to introduce boring operation. So we go for the drill. So there is no coordinate system selection. When you are dealing with turning system, the drill are automatically set for center 0, 0. So under turning operation, all the holes are done at the center. So if the holes aren't at the center, then just know that that is a milling operation. Tool. I'm gonna go for spark drill. I'm gonna take 4.5 mm. Just gonna increase this length to 100 just to avoid collision. Okay, so as you notice, the direction is automatically selected for you. Levels or fine technology, drill start. This is my starting point. Drill end. I want to make sure that I'm selecting this point. Okay, full diameter selected. I'm not gonna use any cycle for now. Link, none, or fine. Simulate, solid verify. Okay. Okay, let's look it in. Boom. Rest material. Okay, or fine. Hold properly. Done. So we do this slot operation. So as I later on said, this is a milling operation, right? So you want to rotate it a little bit this way. Okay, so what I'm going to do is I'm going to come under SolidCam 2.5T. I'm going to take profile operation. Okay, coordinate system. So right now you want to define a new coordinate system. So add coordinate system. So just come over here. You want to take reference to coordinate system 1. This should be selected. Now select face. Now come over the slot and select this particular position. Now you want to make sure that this Z is actually looking upward. So what you're gonna do is just come on a flip. You just have to play with this. Let's flip X, Y, Z. Okay, fine. I think Z is looking upward. Okay, let's flip X to be looking under the direction. Okay, fine. So you want to make sure that Z is looking upward, X should be looking perpendicular to it, and Y in the other sense. So you go for the green check. Okay. Okay, so as you notice, it has been added here, Mark 1 position 2. Go for the green check. Now select the profile or the slot. So this is my slot. Okay, fine. Tool. I'm gonna be using an end mill for this operation. End mill. I'm good with my default end mill, but I'm just gonna increase the length. Okay. Direction properly done. Levels, upper level. Now for a proper selection, if you just select this face, you notice that this doesn't become green. So for a proper selection, you just need to select this point so it becomes green. Depth, just have to rotate. It's all through. So I'm gonna select this down point. Okay, go for the green check. So now I'm gonna give it a distance of -2 in order to go more deep for a proper surface finish. Geometry, just making sure you're working with the right geometry. Okay, left, let's take right. Okay, so left is the perfect one to use. Go for the green check. I just want to make a finishing pass directly. No need for roughing in this case. Let's just take roughing. 0.02, 0.02. Okay, maximum step down of 0.04. Okay, I think we are all fine here. Links, I'm gonna take normal of 0.01, same as slit art. Okay, all fine. Save calculate. So as you notice, when I save calculate it, it's gonna put it under Mark 1 position 2, as you notice. So now guys, simulate. So guys, this is a milling operation, so I come under solid verify for this and not milling system. So I'm gonna verify this. Okay, so the operation is happening. I'm gonna speed up. So as you notice, it has been equally done from the other side. Rest material. Okay, so our slot has been achieved, our hole has been achieved. So what is left right now is this extra material, the extra material used for clamping. So I have to remove that. So what I do is, in order to remove that extra material for clamping, we use what we call cut off operation. SolidCam Thinning, cut off operation, solid, new. So in the next tutorial, I'm going to be showing you guys how you can actually use wire frame. So where do I want to separate the piece? It's at this point. So I'm going to select this point. Where should I end? It's still at this point. Okay, let me just show you guys the direction. So you want to make sure that you are getting from upward to downward, just like facing operation. It comes from upward to downward. Okay, go for the green check. Okay, so we'll come under modify geometry. We want to make sure that auto extend is on. Okay, go for the green check. Tool, we are going to be using a groove tool, so I'm going to select my groove tool already present, this one, making sure the direction is properly selected. This direction, fine. Levels, no levels. Technology, I want to make sure this is fine. Okay, I don't need any offset, I just want a finishing pass directly. No need for offset. Link or fine or done. Save, calculate, simulate. So cut off operation is a turning process, so I go for turning simulation. I'm just gonna slow the speed down, simulate, and that is it. So as you do notice, this orange part clearly indicates that our operation is totally done. So we are done here. Okay, perfect. Solid verify, simulate. Okay, fine. So it's as you notice, right? This is our job. This is the extra material that was actually helping for clamping. So it has been separated from our final product. So we got this product. So this, what happens is final product is just gonna fall into the CNC machine. So we just pick it and then we clean it, and then our operation is finished. Okay guys, so with this guys, we are actually done with this project. We are done with the VMS project 6. So I hope you like the project. So in the next tutorial guys, we are going to be seeing more complex part. Guys, kindly like my tutorial, share, and definitely subscribe. So meet you guys in the next tutorial with VMS project 7. Boom.